In this lecture video, I'd like to try to bring some clarity to a transistor and how it operates. So a transistor is essentially a switch element. It's essentially a digitally operated switching, something that digitally performs a switch function. And you can combine those switches together to make different things like AND gates, OR gates, etc., and amplifiers, etc. So I would like to just sort of do some handwriting here just to walk you through building a simple transistor circuit to show you how a transistor works. And in this course, I do want to tell you about PNP transistors, but it's in this course in first year, I'm just introducing you to transistors. So I'm going to focus on NPN transistors. I want you to look to the video that I posted on Econostoga for the difference between NPN and PNP. And I'm going to just hone in on the operation of an NPN transistor, and that's what I want you to know in this course. So an NPN transistor, as you know from reading this lecture note, has this operation that is essentially a diode in it. And it is drawn like this. So this is the transistor element, where this is a collector, this is emitter. An arrow always points to the N side, and the N in NPN is on the outside. So this is pointing out. So that's our transistor element, and here this is the base. So it's the same as what's in the lecture notes, it just doesn't have a circle around it. Now I will draw the rest of a useful circuit around this transistor. I'm going to take the emitter and I'm going to connect that to ground. I'm going to connect the the collector to positive 5 volts. I'm going to have a resistive element, just a resistor, to make sure that that is protected. And then from the base, I'm going to purposely apply a voltage to the base. And I'm going to make that voltage 2 volts. So that could be a power supply that I am dialing into 2 volts. That power supply is connected to ground, and I am putting some resistance into that circuit. So this is the resist. I don't have to label it, but what is going on here is that I applied 2 volts and as I showed up here in an NPN transistor, then if you give a positive voltage to the base, then it means that the collector to emitter is going to be shorted. So this is the case that I just drew. So it turns the transistor on. So this is going to be on, or it is in the short. The transistor is in the short state, or it is also called saturated. This saturates the transistor. So what does that give us because of this positive voltage? What does that give us? What that ends up doing, I'm just thinking about how to make this as clear as possible, is that means that the collector to emitter is shorted. So it basically means that everything else goes away and there is a short circuit here. So here's the short. That just means collector and emitter are joined together. So there is a resistor here. And the resistor is going to say, hey, current from this 5 volts, you're going to flow through this resistor. Now you get to here, do you want to go this way or do you want to go this way? Well, it's going to go on the path of least resistance. And in this case, the path of least resistance is straight down to ground. So what I have just done is I have shorted my 5 volts down to ground. So if I were to go and measure right here, and I call this the output voltage and I measure it here, I would get a 0 because it is shorted directly to ground. So what I've done here is I've put a positive voltage in. That gives me a V out if I were to measure it here of 0. So I put basically a 1, binary 1 in. Well, let's just not worry about that right now. So what I've got is a 0 volts out. If I were to measure it right there. So now let's look at the other state, and the other state is if I were to feed 0 volts in. And so let's see, the transistor looks the same because I'm still talking about an NPN transistor. An NPN transistor goes from a collector, a base, down to the emitter, which is an N side, and that's what the transistor looks like. I'm going to connect this to some circuitry that also has the resistor going to positive 5 volts. That's just the circuit that I'm working with right now to illustrate this concept to you. I'm also going to connect to ground. And so this base, I'm going to still have that resistive element in there, the resistor at the base. But now I'm not going to give it 2 volts. I'm going to give it a 0 volts in. What have I done? Oh dear. I just connected these entirely in the wrong spot and you were probably cringing. There we go. And now I'm connecting this to 0 volts. And what happens when I connect to 0 volts is collector to emitter stays open. So this is now open. Oops. This is now open. So it's open here and open here. So let's look at the path that this 5 volts is going to travel. It's going to travel down here, going to travel here, and it's going to ground itself. That is absolutely the path that it is going to travel on. So it can no longer go down here. It is going to travel through from collector to base and to whatever's going on over here, which is ground. So that means that if I were to measure this voltage here, you would still have that 5 volts as it travels through. And this case is called open, or it's called off, or it's called cutoff. The transistor is cut off. So that's when we feed it a 0. Here we fed it a 0, and here we fed it a positive. And that's a simple way of describing transistors. And I hope to show you more illustrations of some different circuits full of transistors in class. Now, if I were to scroll down here, I also see NPN transistor acting as a switch. And what you'll see is that it's a very similar drawing to what I just did. This is not the switch, by the way. This is just equivalent to me giving it a voltage, VCC. All right, so that's not the switch we're talking about. This is the switch. This is acting as a switch. So as I said here, when you put sufficient voltage on the base, then it is going to close. So if you put sufficient voltage here, say plus 2 volts in my example, you close this, you put plus 2 volts, then this is going to close here, and you have closed this switch. If you close this switch and you give it 0 volts, then it is going to stay open, and it is essentially not, it does not let the current travel through here. So that, what I drew above actually does have it work as a switch. Now, knowing that these are switches, let's take a look, and here it is as a switch again. So if you give it a positive signal here, or sorry, you give it a 1 here. If you give it a 1, then this is going to short out. If it shorts out, then you've got this 0 volts from ground all the way up here, and you would get 0 volts out if you put 1 in. So put 1 in, you get 0 out. Now let's put a 0 in. Then that means that your current is going to go this way. And then your voltage here is going to be the same as here, which is a 1. Okay, so your current, you can measure your current here, and it is a 1. It's in this circuit. Okay, so now the logic and. You can see if you give this a 1, 1, then it's going to close this and close this, which means that this value of 1 is now going to connect here. And however, be careful, this resistor is in a different spot than where we had it before. So before we had, when at the beginning of this video, I showed it like this, a resistor, and then I measured V out, and then there was ground. And this, of course, would be 0 volts because it's directly connected to ground. However, what I'm showing now is essentially going through a couple of transistors as switches. So it went through this one, which was closed, and then it went through the other one, which is closed here, here and here. So it went through the first transistor, went through the second transistor, and then it has a resistor and ground. So now if we were to measure V out here, it would equal 0 because this is directly connected to ground. But we're not measuring V out there. We're measuring V out here. And the V out here is directly proportional to what this R is. So this is your voltage divider. So it'll be according to your voltage divider formula that you know from electrical principles, and it is not 0. All right. So when you put that 1 and that 1 in, what you measure here is going to be not 0. It is a 1. All right. So that's this one here. As soon as you throw a 0, then what's going to happen is this is going to open. And now if that has opened, if that has opened, there's no way for this voltage to get through anymore. It's blocked. So there's no way that you're going to be able to measure a 1 here. You would measure a 0 because there it is blocked. Also, you can block it here as well. There it is blocked. You would measure a 0. So that's how you make a logic AND gate. Logic, or you can follow this same logic. If you gave this a 1, then this would close. If that closed, let's see where we're measuring. We're measuring here. If that closed, then I'm going to be able to take this voltage down. And yes, where I'm measuring, there is a voltage. Okay. Now, oops, there will be, this voltage will be present here. Now, so that's A is 1, and there is a voltage present. Now, if I were to say give a 1, 1, which is this case, now this one is closed, and of course, now you have voltage again. So it would be, whoops, this one goes this way. And of course, you're going to have that positive or that greater than 0 result again. So now let's look at the case where we have 0, 0 going in, and just make sure that that aligns with our truth table here. So let's work through it from scratch here. So 0 and 0. Now what's going to happen is this is going to be blocked right here. This is open. And so nothing came through at all. So this just went here, and this just went here, and nothing happened at all. Therefore, this is going to get a 0 over here, and this case works out. I just want to clarify something up here. I really described this wrong. Is that this is a wrong way to describe this circuit. When I apply a 0 to this base, all that doesn't close this circuit so that it can come this way. When I apply a 0, all it does is opens up right here. So it makes this an open circuit. And what happens is then I can only, this is my only circuit right here. And I apologize for making that error. It's that over here, all this is sort of an input. It's just a signal to the transistor. That's just a signal to the transistor, and the circuit itself is just here, the circuit. So this is just the base signal over here, but this is the actual circuit. So that's why you're just going positive 5 volts to the collector. Of course, that's going to sit there at its positive 5 volts. Okay, so that was just a way of going through and trying to clarify what a transistor is. I have a lot more examples and I'd like to work through them sort of carefully with you in synchronous class. So please do attend, and I look forward to working with you then.